for what I need to have done for you guys by Wednesday early morning, Tuesday late night. So, anyway, if you come in at any point today and I am being antisocial, like with headphones in, just come and tap on me if you need anything, because my top priority is helping you. But otherwise, just also know that I'm horrible at multitasking, especially when kids are in the room. I love interacting with you guys. I love hanging out with you guys. I love talking life with you guys, but that also means I don't get my work done when I'm here in my room and you're here too. So if you need me, just come tap on me, but otherwise, don't think that I hate you or I'm ignoring you. Please, please, please get my attention if you need me, but otherwise I'm just going to be like in my own little zone today. Which some of you realize, right, Kyle? It's like you need your own zone, so then I'm going to try to be in my zone if you don't, when you don't need me today. Sound good? Okay, but I know some of you guys, corrections, keeping up with things, or trying to catch up with things. Please, 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 don't be afraid just to tap me, because please know that I'd much rather help you, and I'll do my work later if I need to, but otherwise. So you guys have your integration as net change packet out. You guys are turning in corrections by the end of the day to get it into the grading period. And the integration as net change is due on Wednesday. Did I pretty much recap everything that's important? I think so. Andre, what's up, kid?
Oh, okay, I just saw your...
That was the majority of my day yesterday. Okay, so for you guys, I am in your Google Classroom where we have the answer key to integration as net change. I know it's not as gorgeous and pretty as the ones I normally do, because if you guys can tell, this is totally not my writing. Because I totally actually stole this from a very cool website of a teacher. I actually forget where he teaches. But his name is Calculus Maximus. And he tries to be like all Roman, I don't know, something centurion-ish, I don't know, in his classroom. I doubt it's a Christian school. But anyway, Calculus Maximus is his website, and he teaches both AB and BC, and he has great resources. I think he even has recordings of his lectures. Anyway, I try to expose you guys to like CalcAB, Patrick JMT. I know you have Slater, but Slater is not usually an excellent resource for your guys' understanding getting deeper. Yes, maybe on a problem, on a concept. Yes, maybe on like a little discussion board of which solution was the best. Slater can help on a problem here and there, but as far as concept delivery and understanding and depth of mastery, Slater's not going to get you there. So anyway, yes, there's CalcAB, yes, there's Patrick JMT, but there's also this teacher, Calculus Maximus. Anyway, this is his answer key to his worksheet. I've kind of tailored a few of his worksheets in both of my AP Calculus classes. You guys can tell some of this is my writing, but and I added in a few of these things also. But anyway, oh, Calculus Maximus. Just kidding, it's right there in your handout. But there is a key. It's a little messy, it's a little out there, but it is accurate for you guys to check through. However, let's just get into this thing and let's see where you guys have gotten stuck, if you guys have gotten stuck. But let's quickly remind ourselves where we've been. Now, this isn't exactly the forever card, but it is kind of close. This is motion summary, but we also have integration as net change in our forevers, right? I think it's still up there on the board. It was only in the test in one place. I ended up making the bonus an equation of a tangent line because we hadn't done this packet. I was like, I may as well give them a fighting chance at the bonus. But why in your forever card are there two different formulas that are basically saying the same thing? Why did I put two different formulas in your forever card? Position is very specific in application to motion. True? Now wait a minute. Does everything move? Austin just did because he just yawned. Kyle just did because he shook his head. My coffee just did because his temperature is going down because it was hot coffee, right? Up until it gets to room temperature, it's getting close, but it's not quite there. What else is moving? Age is moving. All of us have just gotten how many seconds older than when we walked in, minutes older than when we walked in today, right? What else is moving? Temperature outside. We can talk about that temperature too, right? What else is moving? Our lungs, our breath. Like, okay, motion, I get it. Almost everything that's living, breathing, like a lot of different, yeah, there's a lot of movement. The stock market right now is movement. The political climate of our, never mind, let's just not even go there. Coming back. There's a lot of movement, true, but when I say motion in calculus, what am I specifically talking about? Yeah, like actual physical displacement of an object, as in moving feet per second or miles per hour, or, okay, change in distance over change in time, specifically talking about one object moving from one place to another. Not like the temperature in my coffee going down, even though there's no actual, like the coffee isn't, well, I'm moving it, right? But now I'm not moving it. Okay, so motion. Motion is like a specific object moving in a specific place. What's the other category? Look at the top. It's right there. Forever number 42 on the wall. Amount. Amount. Right? Amount. So if we're trying to talk about position, position is modeled by X or by S. What's position's rate defined to be? The rate of change of position is also known as velocity. But when I'm talking about some random amount that's changing, degrees Fahrenheit in my coffee, or age in terms of years or seconds or minutes or whatever we want to put it, or the amount of water inside a container, or let's be looking throughout this entire packet for what are the different amounts that they're measuring. So whatever the amount is, that's F, and then what's inside of the integral? This quantity's prime. This quantity is prime, but what's another way of saying prime? Rate. So is velocity a rate? Yes. Is F a rate? No. But could they call F a rate? Yes. Which is why I'm going to put up here on the board one other variation as integration of net change. This makes it 3. And some of you, I think I've shown it. I think I did show it. And maybe you want to add it to your forever card, maybe you don't. But we could think about antiderivative of B, and this is the amount. The amount at B is the amount at A, the initial, plus the change, and the change comes from how much change occurred. Taking the integral of the rate. I'm going to put R of T just to keep it simple. But I could make it little f of T. Where R is the rate. That's another way of looking at it, because just a few of you, when I wrote prime on that forever card, you got confused. Okay, here we go. We're going to do 1 or 2 multiple choice, then we're going to go to the long answer and see where those of you that did try it got stuck and what you want to talk about first to reward you for looking through and see. Not that I don't want to go problem by problem, but I want to reward those that did go ahead and make their way through and have actual questions they don't understand. Let's start with number 1. Number 1, whenever you see anything that has to do with word problems, rate and amount. Huge idea. One of the top 3, actually, 2 out of the top 3 in some ways. Especially 1 out of the top 3 concepts that the College Board says AP Calculus is meant to teach. Rate. Okay, whenever you see rate or you see amount, you need to ask yourselves the following question. What am I given and what am I trying to find? So, this graph is of what? What is this graph of? Rate with respect to time. You see the hours? Oh my goodness, I totally disoriented this morning. Rate with respect to time. Nope. All right. Well, we'll just orient it again. That's fine. Okay, so as you guys are looking at the problem, rate with respect to time, what are they asking you to find? What you've been given is a graph that at least gives us some information about rate. But what are you supposed to find? So is that amount? Yes, it is amount. Does that make sense? Are we tracking?
Yes.
So they give us an equation, not an equation, but they give us a graph of rate, and they're asking for gallons. They want amount. So question, guys, if rate is inside the integral and amount is outside, then how am I supposed to be looking at this graph? Area. Good. Yep. I'm given rate. Where's the rate? Inside the integral. How do I think about an integral with a graph? Area. So they're trying to find the amount that changed. Oh, the change. They just want the integral. They just want the area. Between what time? They don't tell us the between time. Wait, they do, because they say in how much time? In 24 hours, which means starting from 0 and going to, does that make logical sense? Now, wait a minute. How am I supposed to know area? There's curvy things. Oh, wait. Question. How much area is in a square? Base times height, right?
Yeah.
And what's the distance between 8 and 24?
6.
I'm just thinking
How high? We have 6 by 50. So how much area in one square? 300. How many 300s? Go. You don't need to. How many 300s? Count the squares.
Like full 300?
Do the best you can. You have to approximate. How many 300s?
About 8.
Come on, John, count the squares.
About 8 full 300s.
Best approximation. I see 1, 2, 3, 4, 5, 6, 7. I see 8 full. I see 9 with like a little baby. I see 10. I see more than 11. So what's 11 times 300? So what's more than 11?
Wow.
Does that make sense?
Actually,
Yeah, right? Because they give us rate. Does it make sense? Rate is inside the integral. Change is just the integral. Well, integral is area. Sweet, let's find the area. Is that cool? Good, you should be.
So we don't actually have to show like that.
Nah, this is approximate. Multiple choice are meant to go fairly quickly if you know the idea. Every now and then there's a multiple choice that requires quite a bit of work. They're meant to go fairly quickly as long as you can attach an idea. What's going on here? No longer a graph, now we're given a table. And a table of what?
Acceleration.
Now, could acceleration be an amount?
Yes.
Sure, the amount would be the acceleration itself, right? Could acceleration also be a rate? Who is acceleration the rate of?
Rate of rate?
Yeah, but rate of acceleration is motion, right? He's the second derivative. Who would the first derivative be? He's only one derivative past velocity. Isn't acceleration changing the velocity? Remember the speedometer? The accelerator pedal is changing your velocity. And then he could be, here we go, ready? Kyle, you were going back to position. He could also be the rate of position. So it's either I think of him as an A, or I think of him as a prime of someone, or I think of him as a double prime of someone. What does this problem need me to think of him as? Is it asking for an acceleration? Is it asking,
Velocity.
But what's the key word? Yes, of velocity. At. Do they want to know just how much it's changed? No. Remember, if they just want change, we're talking about change over an interval. Like the 24 hours we just talked about. Amount at. Ooh, there's that at. So, question is, we don't just need an integral, don't we also need a change? Sorry, don't we also need an addition? Okay. We need some sort of initial where it started, and it doesn't have to be at 0, but it could be. Some sort of initial plus some sort of change. Now, hold on. It says 0 to 15, true? Okay. So 0 to 15. 0 to 15. Initial, well, it says from 0 to 15, so I better figure out my velocity at 0, and I'm trying to figure out my velocity at 15, but I'm going to have to put an approximate. Why? Why do I have to figure out an approximate? They tell us this. We know that for sure. It's for sure 5. So wouldn't it be equals?
No.
No, because do you have a function to actually take the integral? No. So wait a minute. I have to somehow approximate area with a table? How does it say to do it? Oh my goodness. I'm doing a trapezoidal sum to approximate an integral to be able to figure out a final amount. Do you see how all these ideas are starting to Trapezoidal sum, isn't that one that used 1/2 base times height 1 plus height 2?
Yes.
Which is another way of saying it as 1/2 my delta x's, which are delta t's, times my a of t1 plus a of t2, because that's my function this time, if you want to make it all precise. How many trapezoids am I doing? They don't tell me, so how'd you get 6? I'm getting 5. So I only have 5 jumps. I only have 5 jumps. Now, guys, isn't 1/2 going to be outside all of my trapezoids?
Keep it outside.
Do you realize how I'm going to want to throw this all in my calculator in a second anyway? So I'm going to go ahead and just write this next to my 5 plus, instead of doing, which I could do, A1, A2, A3, A4, A5. Hi, computer. Good morning. It's Monday. Time for you to wake up. Oh, that didn't work. 2, 3, 4, 5. I don't even know. I could write out each and every one, but this is a calculator problem. We're allowed to go to our calculator. Maybe not for the whole packet, but definitely for here. So let's use it. But the problem is, oh, wait a minute. It's not a problem. What's nice about each of these 5 jumps? They're even. 3, 3, 3, 3. So I don't just have the 1/2 in the trapezoid formula. I also have a 3 because all the bases are even. Well, that makes my life a little easier. And how do trapezoids work? Wouldn't the first one have 1/2 times the change in base, aka the jumpity jump of 3, times height 1 plus height 2, which is 4 plus 8? Isn't the second one going to have 8 plus the next guy, which is 6? Isn't the next guy going to have 6 plus 9 and 9 plus 10 and then 10 plus 10? Yeah. If you want to think about it, you can say, well, it's 4 plus 8 and then it's 8 plus 6. Wait a minute, how many 8s are there going to be? 2 used for that trapezoid and that trapezoid. If you want to, you could go 16 or you could be super safe and realize mental math mistakes happen a lot. If it was a non-calculator, we'd have to do some math right now, right? If it was a calculator, we could just throw it in. Just because some of you, do you have your calculators out? Just seeing if I can beat you. Do you guys have it?
No.
I have 20, 40, 50, 60, 70, 80. Divided by 2 is 40, times 3 is 120. I believe, double check. Oh, I just got it wrong. Why? This is 120. This is the change. What did I forget? Because I was having too much fun with my mental math. See how it was just there begging to be chosen? Woo! That was close.
That was fun.
Does that make sense? Okay, we did a couple multiple choice, and then I said I was going to reward those that worked on it this weekend and got stuck. Does anybody have a place they want us to jump to? We have some long answers. I think we did 3 and 4, or 3 and 5 the other day before our test. So we've already done a few others of the multiple choice. Tell me where to go. Which one? 6B. All right, if you guys want to jump there, 6B, we're going into a long answer. Free response. There are multiple choice on the AP exam. There are free response. Free response can involve all sorts of things. Derivatives, integrals, areas. Okay, first of all, we need to know what we've been given. So what is this? It's a function, which means we can probably go to our calculator. It's an at. It tells you what at? The temperature outside, right? Okay, so I have kind of like an amount equation. It's like, okay, how many degrees is it outside? Cool. Letter B says an air conditioner cooled the house. P.S. If you guys want to hit on letter A. If I want average of what I already have, what formula do I need to use? I'm not plugging in for you, but I am telling you what you better want to use. Average value. It doesn't want the rate. It wants the average of what I already have. Anyway, sorry. Letter B. An air conditioner cooled the house whenever the outside temperature was at or above 78. At or above 78. For what values of T was the air conditioner cooling the house? Guys, this is definitely a calculator problem. At or above, I'm pretty sure at or above. I think I can actually practice, can't I? Ooh, healthy C, we did some super cool stuff. Sequences? Anyway.
What's the explanation?
Factorials. Remember last year when we did like probability?
Oh, yeah.
Okay. If I were you, I would throw this into your y equals, which is 80 minus 10 cosine 80 minus 10. Cosine of, what was it? Pi T over 12? I'm just gonna put pi x or whatever. Is it over 12? Okay. They just said at or above 78 degrees, which I know that, and they said 24 hours. So I'm gonna make this go to 24 hours. Make sure I have that 24-hour interval. I'm going to go up to, I don't know, what do you guys think? We live in California, so go up to 100 degrees.
Oh, so you just grab.
Well, we probably should go up to global warming. 130. All right, so graph. Oh, wait a minute. I'm supposed to be thinking at or above 78 degrees. Can't I graph the 78 line and see when the temperature is above 78 degrees in between? Ooh, 0 to 24 hours? I can even change that. When does it get hotter than 78 degrees? This time of the day, which you should know, right? Cooler in the morning, cooler in the evening. So, 78 degrees. Wait a minute. Can't I be snazzy and can't I actually find these intersections? Ooh, there's one. Wait, do you guys realize you can be super snazzy and save yourself a lot of time and actually skip back here and hit the still button and be like, I need to keep that number to use it? Hey, guess what? Oh.
That's the worst message to me.
Yeah, this one I should get. Yeah, you can go straight back and hit still or something. Oh, there you go. Still as a. Hey, look, I didn't have to even type it in. Now over here, we're going to be super snazzy in calculus and say, okay, so we have our graph of our cosine curve. We have our 78 degrees. We have our A and we have our B. And we can say, guess what? Intersections are going to be at A equals 5.2308. I'm going to do a dot, dot, dot. I can say B is equal to, the AP guys love it when you just tell them like variables and you use those for the whole problem instead of just writing this out again and again. Saves you time, saves them time. I can come over here and do the same thing. But Kathleen, that was just to figure out when it's above 78 degrees. What are they actually asking me?
For what?
I'm going to type 10 because I don't know. Oh, sorry. For what values what?
So one's like the time interval in which the AC is working.
Sorry, I do over to the other one, and mine is a lot slower than yours. There we go. 18.76. You have to go straight from it having found it to stowing it, otherwise it's not going to like you. But there we go, 18.769. Okay. Oh, hey, we already got it. Cool. So to use it then, as soon as you use A and B, guys, you can use it for the rest of the FRQ, which is awesome. Once you have A and B, you can use it for the rest of the FRQ.
Just like writing A.
Yeah. As long as you assign it, you have to assign what your variables are, but then you can use them. Which is super cool. Now, Kathleen, probably, even though B was tricky, that probably wasn't your main question. I think your main question probably had to do with C, right?
Wait, so for B, would you just
That's it.
like find it, like find the definite integral with those values?
Yeah, this is the final answer.
What?
It says for what values of T. I just gave it.
She said
So I have a question then for the next one.
The next one gets harder.
Okay, but can't you just like
The cost of cooling the house accumulates at a rate of 5 cents per hour for each degree the outside temperature exceeds 78 degrees Fahrenheit. So we know when it exceeds.
for each
We need to get each degree. Wait a minute, each degree, isn't each degree like the area?
And I scoop.
The area? So can we take the integral from A to B of my f of t dt? Wait a minute, I need to multiply that by something, right? That's how many degrees. I also need the 0.05 cents per hour. Per hour per degree.
Times
So this is
5%.
going to give me the degrees.
Isn't it 5%?
Well, 5 cents.
5 cents is 5% of the dollar.
I mean, sure, you could think of it that way.
Then you have to multiply by.
Or per hour.
So,
That works.
What did the area give you that like?
Like units wise?
Yeah.
The area is actually going to give you like this definite integral, degrees Fahrenheit times hours. Because think, feet per second squared goes to feet per second, it's like times second, and then to feet, like times second again, and then if you were to go again. And then the nice thing is, the hours would cancel, which is what you need them to do. And then it's for each degree, 5 cents for each degree. And you can plug and chug that to your calculator because you're not solving that integral by hand because it's a calculator problem. Remember how nice it was just to put in the A and the B? Or I should say to put in a definite integral.
I have a question.
And it's even better because here, yeah.
So do we have to like technically derive F then because it's just an act? It's not the rate.
Well, F is the amount at function, but when you take an integral of it, then you end up getting the accumulation.
Oh, okay, I'm thinking about that.
But I'm thinking of it this way. Ready? If you knew the at like 2 a.m.,
Okay.
what's the at 2:01? Wait, what was the at 2 and 30 seconds? Wait, what was the at 2 and 5 seconds? It's impossible for us to get all the ats. We need the integral to do it for us. Bye, cool kids. I'll see you later. Now do you at least know your, this packet is a thing. We might have one more workday tomorrow. It kind of depends. Last year we did 2 workdays. This year I was hoping for just 1. But what's your job tonight? Actually get into the packet. Your test corrections should be behind you. Get out of here, Chapel Day. I'll see you guys later. Okay, people that still need to turn in corrections, you have until the end of the day, unless you need an extension, which I can't guarantee. Unless you talk to me, that an extension will still get it in by the end of the grading period. See you guys later.